next.
All right, everybody. This is Shenga, your host. SG2 on Space, episode number 30. Wow, can't believe that. 30 weeks straight, pretty much, on Action One Media, which, as you can see, Action One Media Group is the one that supports this program. So SG2, so the only weekly space show in Houston, Texas. In any case, believe you can follow us at www.facebook/The Shen Show, spelled THESHENSHOW. Of course, that's a place you can watch us as well, and any postings on other relevant links or events or whatever else. Of course, you can also watch this on www.weara1.com, so check that out. Of course, there's lots of other good shows on Action One Media as well, so you can check those out as well on that website. Okay, so in any case, I figure we get started a little bit. So, let's see here. So, as always, the format will go as such. First of all, I'll talk about some special things going on. In this case, I have a natural interest in, deflecting asteroids. That's actually what I did my grad school thesis in, partly. So I thought this was interesting. And another thing was going to talk about the great beyond, what is going on, the stuff about gravitational waves, dark matter. Let's see, what the heck. And then, of course, the space entrepreneurs, notably Blue Origin, I thought was pretty crazy. I'm going to show you some launch videos of their latest New Shepard test. And as well as a mention of SpaceX cargo launch happening soon. And lastly, some interesting stuff about aliens. Yes, aliens, which I am talking about the ones that some people still don't believe in. So let's get started here. First of all, this week was the International Academy of Astronautics' IAA, which is the largest nonprofit aerospace organization in the world. They had their Sixth Planetary Defense Conference in College Park, Maryland, where basically all they talk about is how to deflect asteroids, all right, or prevent, all that stuff. So they had a simulated scenario where basically NASA scientists, and among other countries as well, scientists developed a scenario in which scientists in March 2019 discover an asteroid that could impact Earth in April 2027. What the heck are you going to do, right? Let's play a short little video. By the way, just a note that this is a CBS, which doesn't. I'm going to correct what they say after the whole thing goes, because there's the last sentence is very flawed. So, just gonna add on here. Can they hear me?
NASA is preparing for the absolute worst, a large asteroid speeding toward Earth. Unlikely to happen anytime soon, but better to be prepared. Chip Reed takes a look. And remember, this is only a test.
In the movie Armageddon,
the United States government just asked us to save the world.
Bruce Willis helps save the planet from a giant asteroid. The plot is wildly unrealistic, but the danger is potentially real. At a conference in Maryland today, scientists from around the world were asked how to respond to a make-believe scenario in which an asteroid big enough to destroy a major city just might be on track to strike the Earth in 8 years. Dr. Lori Glaze is director of planetary science at NASA.
What are the chances that we're going to need to send Bruce Willis up there to deal with an asteroid?
I don't think we're going to need Bruce Willis.
We can change the standoff detonation distance.
And unlike the movie, we probably wouldn't need to use nuclear weapons. More likely would be using spaceships to give the asteroid a nudge.
All we have to do is change its speed a little faster or a little slower so that when it crosses Earth's orbit, it crosses either in front of us or behind us.
There are 20,000 near-Earth asteroids, and they do occasionally make an appearance. In 2013, one slammed into Russia, injuring 1,600 people.
Is this a threat that keeps you up at night?
It doesn't really keep me up at night.
So you shouldn't lose any sleep either, because no huge asteroids are on track to collide with Earth for at least 100 years. Chip Reed, CBS News, College Park, Maryland.
All right, we are back, and as always noted, these popular media channels, they are not scientists, and so definitely have to clarify the last part. We don't know when an asteroid will hit us, okay? So it's definitely not saying within 100 years. It could happen tomorrow, for all you know. It's like flipping heads or tails on a coin. Probability-wise, flipping heads might be 50%, but does that mean your next flip will be definitely, one or the other? No, it doesn't. So, in fact, just adding a note here, because I have done research on this in the past for a number of years, we have not detected majority of the ones that could basically wipe out a whole city. So there's a whole bunch of those out there. So it's quite an important thing. So just a note before we go on break, this conference lasted a couple of days. So there's two methods. One is to do a kinetic impactor, where basically you hit it. Okay, and you push it. And the other way is to use a standoff nuclear detonation, where you don't hit it with a nuke, but you detonate it and the shock wave pushes it. Okay, so either way could work. The key point, as noted, is you don't want to actually, you can't actually create a huge significant force on this thing. The most you can do is nudge a little bit. That's all you need to do, right? So you either make it go faster or make it go slower. That way, it won't collide with the Earth, right? Earth would either have passed that particular spot already when it comes, or it would pass before Earth gets there. That's the idea. All right. So hopefully this, I'm glad that people are actually talking about this and thinking of these exercises. So let us hope that nothing of this sort will, have to take place in the near future. All right. With that, let's take a quick break, and when we come back, we will talk about some other stuff. All right. You're listening to SG2 on Space.
Put your money where your community is. Get in the action at weareA1.com.
And that was a super quick break. You are listening to SG2 on Space, episode number 30. For sure, you're watching us on www.weareA1.com or on facebook.com/The Shen Show, TheShenshow. We also have YouTube channels, but you can link it from, going to either of those two sources. So with that, Shen Ge here is going to talk a little bit more. So before we went on break, we talked about the Planetary Defense Conference happening, that was happening. Oh, that is actually still happening. April 29th to May 3rd, 2019. Basically, a bunch of scientists internationally gathered together talking about how to deflect asteroids. So that's cool. For the sake of time, we can... Oh, actually, I should mention to you this a little bit more in detail. So the specific elegant solution here does require more than what I just suggested, all right? You have to build and launch within 6 months 2 very complex spacecraft that could fly out to this, say, asteroid and orbit for several years, since you need these exploration spacecrafts to characterize the mass and the volume and basically what these rocks are made of, right? That's actually really important. Then that will gather information that you could use to formulate of, say, where to hit this and with what amount of force, okay? So it's kind of like, if you have a heavy person, then you need to have more force, right, to push that person out of your way versus a smaller, lighter person. Or in terms of asteroid, there's, that analogy kind of holds as well. And there's also the important part that you don't want to break it into pieces. That's really bad, because if you break it into pieces, you got smaller pieces that is really unpredictable, and how are you going to deflect those, So, in any case, it's actually more complicated than you may think. What they said is, okay, then after you gather information, you build and launch 6 missions to block the asteroid's path and slow it down, or push it faster, right? So, as a safety precaution, so the team recommends those 2 spacecrafts. There's 2 spacecrafts. Could also be armed with nuclear devices. All right. So those are the 2 initial spacecrafts that are supposed to do just for exploration. So if you're still not comfortable, at least you have, I guess, a backup plan to detonate those nuclear devices. All right. So, in any case, scary stuff. There's a TV series out. I believe it's called Salvation or something. I kind of want to watch it. I believe it's something similar to this. I would think it'd be better than the Bruce Willis movie, but that's my take on it. All right. So another interesting thing before we go into the great beyond science-y stuff is there's a space art student contest, which I thought was kind of cool. So there's this band. It's called OK Go, which has some, I think they have okay music, decent music, and their music videos are pretty amazing, honestly. So please go watch some of them. One of the music videos is shot in microgravity. So they literally took a whole bunch of clip scenes from, I think, riding the Vomit Comet, the airplane that goes up and down. And they took those scenes, and it seems like they're, it's pretty cool. But anyways, they in April 2019, April this year, they launched this art in space contest. Through its educational nonprofit organization called OK Go Sandbox, where they invite students to dream up your own cool experiments to send into suborbital space on board the New Shepard spacecraft, which we will talk about in a little bit. Okay, so anyway, so students ages 11 to 18 have until May 6, 2019 all right, May 6, 2019, by 11:59 p.m. Central Time to enter the contest, all right, to submit their idea. So if you're a kid between the age of 11 to 18, then, and you have an idea of experiment to do in suborbital space, you should enter it. Why not? And then in June, you'll be notified, okay? So, yeah. Anyways, just a note. All right. Okay, with that, let's go into something more scientifically fabulous. All right. So, remember about a little while back, we talked about, I interviewed my friend Gerardo about the stuff he did with quantum optics, and then kind of related that a little bit. We talked about LIGO, Laser Interferometer Gravitational Wave Observatory, how that uses quantum optics to a degree. Well, guess what? They just discovered new gravitational waves from 5 different sources in just 1 month, which is crazy. That's like the gravitational waves, they are tiny. So before I actually go and talk about their latest discoveries, let's take a moment and hopefully can get this video up where it gives an idea of what exactly gravitational waves are and what role does LIGO actually play in doing that. So this is from one of those cartoon physics little videos, which I think is pretty funny. So let us, let's see what it says.
What is a gravitational wave? It's a ripple in the fabric of space and time. Imagine that space is a giant sheet of rubber. Things that have mass cause that rubber sheet to bend, like a bowling ball on a trampoline. The more mass, the more that space gets bent and distorted by gravity. For example, the reason the Earth goes around the Sun is that the Sun is very massive, causing a big distortion of the space around it. If you just try to move in a straight line around such a big distortion, you will find yourself actually moving in a circle. That's how orbits work. There's not an actual force pulling the planets around, just a bending of the space. Gravitational waves are produced whenever masses accelerate, changing the distortion of space. Everything with mass and/or energy can make gravitational waves. If you and I started to dance around each other, we would also cause ripples in the fabric of space and time, but these would be extremely small, practically undetectable. Now, gravity is very weak in the scale of other forces in the universe, so you need something really, really massive moving very, very fast to make the big ripples that we can detect. How would you observe a ripple in space? If the space between you and me stretched or compressed, we wouldn't notice it if we had made marks on our metaphorical rubber sheet, for example, using equally spaced rocks, because these marks would also get stretched further apart. But there is one ruler that doesn't get stretched, one made using the speed of light. If the space between 2 points gets stretched, then light will take longer to go from one point to the other. And if the space gets squeezed, light takes less time to cross the 2 points. This is where the LIGO experiment comes in. It has 4-kilometer-long tunnels and uses lasers to measure the changes in the distance between the ends of the tunnels. When a gravitational wave comes through, it stretches space in one direction and squeezes space in the other direction. By measuring the interference of the lasers as they bounce between the different points, physicists can measure very precisely whether the space in between has stretched or compressed. And the precision needed is incredible. To detect a gravitational wave, you need to be able to tell when something changes in length by a few parts in 10 to the 23. It's like being able to tell that a stick 1 sextillion meters has shrunk by 5 millimeters. The effect of a gravitational wave is so minuscule and easily confused with random noise, you need a smart data analysis technique. Scientists hope to identify the patterns of gravitational waves by comparing the wiggles they measure in the experiment to the wiggles they expect from the gravitational waves. That's like trying to identify a song being hummed at a noisy party. A very, very noisy party. Imagine your whole life you had been deaf until one day your hearing was restored. You'd be able to explore the universe in this whole new way. That's why detecting gravitational waves is so significant. It's a completely new way of studying the universe. Anytime there's a new way to investigate the universe, we discover things we didn't expect. It's really about looking for new things we didn't know existed, examining the extreme edges of our knowledge of physics, and testing our theories about how the universe works.
Amazing, right? So, I thought that was a very good, informative little video. All right, so LIGO has detected gravitational waves, but what's different this time? Well, it's extraordinary how many they have detected in the last month, actually. So, why had this happened? Well, it's basically there were substantial improvements for the LIGO and Virgo detectors over in the last year and a half. So, what are these discoveries? Okay. So 3 of the newest results appear to be mergers involving 2 black holes, and one seemed to be a merger of 2 super dense neutron stars. All right. 5th candidate, which was found on April 26th, is possibly a collision of a neutron star with a black hole. Fascinating. So that candidate is pretty weak, relatively weak. So it's going to take some time to reach a definitive conclusion about it. So, now, since this first detection in 2015, LIGO has recorded evidence for 2 neutron star mergers, 13 black hole mergers. Yes, those things can merge together. And 1 possible merger of a black hole and neutron star. All right. So, now, neutron star mergers, unlike black holes, that do produce light. So once this thing is discovered, telescopes around the world pretty much scramble to try to, find visible evidence of those events. So researchers were able to actually spot light from the first neutron star merger detected in 2017, actually, using more than 70 ground and space-based telescopes. Amazing, right? So now astronomers are still searching for the 2 most recent detections, the neutron star ones. Okay, April 25th, which was discovered on April 25th and 26th. The first one likely occurred about 500 million light years from Earth. However, only one of the 2 LIGO observatories picked up that signal, so researchers had to search more than a quarter of the sky. Good luck with that. So, just to note, the LIGO is not just one location. There's 2 locations. There's one in Washington State and another in Louisiana. Okay, and there's also a Virgo detector in Italy. Okay, which is based on the same principle. So, then there's a second one which astronomers are scrambling to detect, which may have been a neutron star colliding with a black hole, and that would have been 1.2 billion light years away. That's a billion. All right, that was crazy. That was detected at all 3 sites, so that lets scientists narrow it down to just 3% of the sky. Good job. Hopefully we find that one. That seems like really cool. But also of really interesting note for you guys who's, not working on the LIGO project, which I imagine is both of us, LIGO or Virgo, you can follow along. They have recently implemented this automated public alert system. So they have a Twitter account, which I will share later. So you can basically follow along every time they detect something. Of course, they put out news, whatever. So this is going to be cool, considering how frequently they're discovering things. I can't wait to see what this month will bring. Who knows? Maybe there'll be 10 discoveries. I mean, these seem to be fairly common throughout the universe, amazingly enough. So, all right. With that said, another fascinating thing in this universe is dark matter, right? I've mentioned that before. So dark matter, no one knows what it is, but it's supposed to make up about 85% of the matter in the universe. We can't see it. The only way we know it exists is that it has gravity. Otherwise, our galaxy would not be held together, okay? And the stars would not be orbiting the center of the galaxy as it is. In fact, our galaxy would not exist because there wouldn't be enough mass to, like I said, to actually have a galaxy. All right, so, but what exactly is dark matter? You can't see it. Generally it's no light. We don't think it's planets out there. That'd be weird to have that much mass. So it's just purely unobservable planets. Probably not black holes. Some might be, but 85% of the known universe? That's a lot. All right. So one thing that people thought it might be is what's known as WIMPs, which is a funny name. It stands for Weakly Interacting Massive Particles, which is exactly as the name suggests, like gigantic heavy mass particles that does not interact much. All right, so hence very hard to detect. All right, so any case, there was this recent, there's this experiment called Xenon, Xenon, which I'm sure stands for something, but I'm not quite sure what. So the xenon is aiming to detect, candidate dark matter particles known as WIMPs, right? So for this reason, the facility is located deep underground, so it can avoid interference from other sources, such as neutrinos, all right, which, by the way, is also extremely weakly interacting. But, in order not to skew the results, you don't want neutrinos either. So, so what exactly are you looking for? Well, in the case of the xenon experiment, this required observing a chamber filled with liquid xenon-124 for signs of particle interactions. All right. So this would have been really cool, right? So if they observed some changes, then that would have been like awesome. Now, this is a little misnomer. Unfortunately, the dark matter detector did not detect evidence of WIMPs yet. But what did they discover? They discovered the first ever decay of xenon-124 atomic nuclei. All right, that's a pretty huge accomplishment. Why is that? It's because the xenon-124 is, it's not a stable isotope, but its half-life is about 1 trillion times longer than the age of the universe itself. All right, the age of the universe right now is about 13.8 billion years. So this makes this radioactive decay they observed, the so-called double electron capture of xenon-124, the rarest process ever detected in a detector. So just to give you a little chemistry background, xenon-124, actually, can anybody guess how many protons xenon have? Okay, 54. So with 54 protons, 70 neutrons, all right? So what happens here in this particular process known as a double electron capture? Sure. All right, so in this double electron capture, let me finish this up. So 2 protons in the nucleus simultaneously catch 2 electrons from the innermost shell, will transform them into 2 neutrons, and then spit out 2 neutrinos. Okay, so they basically detected this stuff, which is pretty rare. Like I said, the half-life is exactly, it's 1.8 times 10 to the 22nd years, which is amazing. So, all right, I think we have a phone call coming in, or rather, let's see if there is. I suppose we'll find out. So just a note here that this did take about a year's worth of observations. It's not like, hey, they just set this up and then next day they discover this. It is a hope that these scientists, they think, hey, wait a minute, we can detect something so rare, even though it's not a WIMP. It means we could really. It basically shows that yes, it's extremely sensitive. So there's a lot of hope that maybe we'll discover a weakly interacting massive particle in the near future with this. So just to note, xenon, this experiment is not the only one. There's a number of other experiments that are, I believe, also located deep underground, and which is, hopefully some of them yield results, right? That's all we can hope for right now. So. Okay, so, all right, let's see here. With this note, I could talk more about science, but here's the deal. Why not go into what is really interesting in terms of the space entrepreneur world? I figured that would be cool. So, a little note before I was going to say this a little bit before, but hey, SpaceX cargo launch, by the way, guys, that is launching at 3:11 a.m. American Eastern time on May 3rd. All right, that's 3 a.m. Okay, if you want to stay up, sure. Or if you're somewhere else around the world, I imagine you could actually do it. That's 7:11 GMT. So, just a note, that's just a fairly typical now cargo carrying mission, the Robotic Dragon, okay, going up to the space station, 5,500 pounds of fresh supplies, experimental hardware, payloads, whatever else the astronauts do and use and experiments. So that's cool. All right, it got delayed a couple times due to some power issue on the space station. So finally, it's all remedied thanks to diligent robotics work. So it's in good shape now to support this launch, the CRS-17 launch. So good job, NASA. All right. So, okay. All right, then. I think All right. So I think we are getting someone to call in.
Yeah.
So let's do it.
Yes. Hi, yes. Can you hear me?
Hmm?
Hello?
Hey, Zach.
Yes.
Hello?
Hi, Shen.
Is that you?
Yes, this is me. First of all, doing a great job on the show. A lot of amazing facts that I have not even touched base on yet. I do have a question, though. I'm
Go ahead.
not sure, maybe you touched up on it in this episode, but when you first laid eyes on the picture of the black hole, what was your initial reaction, and did it inspire any creativity out of you?
That's an excellent question. Wow, that's different. Go figure from a poet, right? So, I don't think I saw a picture of a black hole. So, I mean, I see representations of black holes, but did it inspire a sense of creativity in me? I think every time I see a space picture, it happens. Like, I feel really inspired. And I'm like, wow, there's amazing things happening in the universe. And, in some way we're able to observe it. Like, it's interesting from the scientific perspective, but for me, it also hits me, in the heart, right? So, and I see the beauty there and the wonder in the universe. I think it does some of my poetry that I've written, I think arose from that, I would say. Does that answer your question?
Oh, yes. Yes. So I guess in that case, maybe a sub question. Is there any space picture that you've laid eyes upon that just stands out to you and you've carried that image with you in your mind throughout your life?
Yeah, so a lot of the nebulas that I've seen, also the some pictures of the Earth from the night, from the space station, also the moonrise picture that one of the Apollo astronauts took. I forget which one, where basically the Earth is like this tiny, stuff in the background from the moon surface. Also, there was one where the Cassini spacecraft, I believe, took a picture of the moon. Not the moon, sorry. Picture of the Earth through Saturn's rings a year or two ago. And that was utterly amazing, showing how tiny our planet is, even from Saturn. And like I said, a lot of the nebula pictures, like Cat's Eye, I love that one. Crab Nebula, the Horsehead Nebula, I could name a bunch. Yeah, so... I mean, those are, of course, I also like a lot of the imaginary landscape ones, that artists draw up. Doesn't have to be real photos. So and the Milky Way. Photos of the Milky Way is beautiful, and photos of other galaxies are also incredibly beautiful. So, like M31, the Andromeda Galaxy, fabulous. So,
Definitely. Well, thank you very much for taking the time with me to speak to me. And
yeah, no problem. You can call me anytime.
Definitely keep doing what you're doing, and just all around, amazing job.
Well, thank you. I mean, if I think I will share with you later, but a lot of the poetry I write, is space related. So.
That's right. I've read a few, and if you want, I'm not sure if you're allowed to do this on your show, but if you want to plug yourself for next week.
I mean, who knows? I mean, I'm sorry. What did you just say?
I said I'm not sure if you're allowed to do this on your show, but if you want to plug yourself for what's coming up next week.
Ah, yes. Zach, while you're on the call, why not? So maybe you want to talk about what you do as well.
Oh, wow. Okay. Well, every first Monday I host an open mic at Nocturne in the southeast side of Houston, and all are welcome, of course. We usually have a straight open mic unless we have a featured poet, and this month's featured poet is none other than Shen, and he will be promoting his book as well as some new work I can imagine, and he will be enlightening us with his intergalactic posy.
I wouldn't call it intergalactic, but thank you for that pitch. Yes, I almost forgot, honestly. But so basically, for those of you who missed that, there's a Zach basically who called in, does a monthly poetry open mic, and I'm the invited featured poet for next Monday at 7:30 p.m. at this place called Nocturne, Nokturne, down in Webster, Texas, which is about 5 minutes from Johnson Space Center, NASA, which, if you're local, it's not a huge deal. So, and yes, a good portion of my poetry is space related, or, talks about stars and things, even if it's metaphorically. So thanks, Zach. All right.
Of course. Thank you.
Appreciate it.
Thank you.
Thank you. All right. Okay, so that was fun. With that, like I said, we got to talk about, what is it? Blue Origin, New Shepard, amazing. They just concluded their 11th test mission on May 2nd. And it's truly fabulous. I mean, this is a reusable rocket capsule, right? So this basically makes it the 5th time that's flown to space and back, all right? And everything went without a hitch. It's beautiful. Just a note on Blue Origin, remember, it is funded by the richest man in the world, which is Jeff Bezos, founder and CEO of Amazon. And he dumps at least, I believe, $50 million into Blue Origin every year, and he said he's going to dump more if needed. So eventually, hey, with that amount of money, of course, good things will happen, and of course, really smart people too. So this was out. The New Shepard rose off a pad at West Texas test site at 9:35 Eastern time, and if we can hopefully play a few after we go on a little short break, which we will do so. When we come back, we'll play a little few scenes. You will be able to see the launch scene and, of course, the descent. Since, like I said, this thing's reusable. Cool stuff, right? So, with that, let's take a little short break. You're listening to SG2 on Space, episode number 30.
Put your money where your community is. Get in the action. Action 1. Independent thinkers working together. Inspiring action in media. Get in the action. Inspire today. Join us by being a sponsor at weareA1.com.
Growing up as a black kid in New Jersey, all I ever wanted to do was be a pro athlete. All of my role models were black athletes. And every time I would stare out the window, look at the sky, and wonder what I'd be in the future, it always had to do with me catching some crazy football and scoring a touchdown. When it came to the point that I was told that I would not be able to play on an organized sports team for the rest of my life, it was something that I really didn't even know how to stomach in the moment. And I remember walking out of my cardiologist's office and just sitting in the hallway and breaking down for a few minutes just because it was something that I just couldn't plan for and couldn't account for. And I realized that in that moment, my entire life was going to be changed. And all of those dreams and hopes and aspirations that I had were going to go out of the window.
Man, you still here? Go on and subscribe. Get in action.
Yo, we back at it again, baby.
What?
Get in action.
3,
Get in reaction.
Tell me what is the deal, tell me what is the deal.
So I challenge you today to start strong.
Get in the action. Tell me what is the deal. Cause I'm calling for you.
Get in reaction.
Can you feel that? Yeah. See, I'm calling for you. Can you feel that? Yeah. See, I'm calling for you. Can you feel that? Yeah. See, I'm calling for you.
All right, and we are back. SG2 episode number 30. SG2 on space, I'm sorry. The only weekly space radio show here in Houston, Texas. Platform is Action One Media, so you are hearing us on www.weara1.com. And, of course, facebook.com/The Shen Show, THESHENSHOW. If you miss us live, all shows are on YouTube permanently. All right? Hopefully permanently. But point is, this show we have talked about deflecting asteroids, space art, a student contest made by this man called OK Go, LIGO, Laser Interferometer Gravitational Wave Observatory, and Virgo as well in Italy, detecting a bunch of gravitational waves, 5 of them exactly. Black hole mergers and neutron star mergers and all that. Dark matter detector, not yet detected in the universe, the decay of a xenon 124 atom. And talking about the fact that SpaceX is launching soon. In fact, 3 o'clock in the morning for Eastern time, or 7:11 GMT, Greenwich Medium Time, which is the same as UTC, I believe, which I guess if you're scientists, you might use that, or engineers. But and then before we got our call, we're actually going to show what Blue Origin just did, which was amazing, launching the New Shepard spacecraft. So let's see if we can find some of that video clip. So the whole live video was like 45 minutes. We obviously would not play the whole thing because most of it's just commentary. So we're going to skip around to a few particular sections, which includes launch and descent. So let's see. Launch, first of all.
Terminal flight profile, it's what you and I are going to. Capsule is going to separate from the rocket, continue up over 100 kilometers. That's when you're going to get the 3 to 4 minutes of zero-G freedom, taking in those beautiful views. And then the capsule, of course, will come down under the parachutes and retrothrust system that will create the air cushion just in the last milliseconds. The booster itself, of course, will continue up to its own apogee and come in for a nice soft landing just 2 miles north of where it's taken off from. So cool. Now,
okay, so that was a short mission profile of what it does. Okay, so suborbital, right? It doesn't actually orbit the Earth. It goes and then comes back down. Remember, that's what that band was going to have. So if you do the space art experiment, you're going to go into one of these things, all right? Your kid's experiment, or you if you're a kid, all right? Okay, so that was a mission profile, and now let's see the launch part. The typical T minus blah, 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 right? So, which is kind of cool. So that starts from 29 minutes and 5 seconds and goes until 32 minutes and 58 seconds. So the launch is essentially divided into, well, actually, I would say it's better to see than for me to explain. But suffice it to say, you will notice that it has both a rocket portion and a capsule portion. All right. Remember, this is completely a test, so there's no astronauts inside. It's not human rated, and but it did have some payloads. So in fact, it did have like 38 experiments up there inside. So it was legit. All right. So
to be used for payloads the newest capsule that's going to be flying humans later this year. It's in the barn, not too far away from me. And because it's such a special capsule to us, we actually decided to name the newest capsule that's just in the barn the RSS First Step. RSS, reusable spaceship, of course, right? And First Step because it is our first capsule that is going to be taking people. It's going to enable our vision of millions of people living and working in space. So cool, right? All right, the bridge is retracting. Guys, we're about to launch a rocket. Let's turn it over and listen in on pad audio as New Shepard comes alive for space. New Shepard at this point completely autonomous, starting at T-minus 2 minutes. She's going to be running through her last bit checks. There you go, aft fin checks, 4 of those fins, supporting the directional capability of the rocket. And then shortly here, we're going to see the BE-3 engine nozzle gimbal also supports the directional capability of the rocket. All the while, I know our team is in mission control, keeping their eyes on the temperature and the pressures in the propellant tank. Man, I have said this before, but there's nothing like a ticking clock and a rocket behind you to get your heart going. Guys, it's time to go to space. Let's get ready to rumble, New Shepard. Look at her go. Mission Control has confirmed New Shepard has cleared the tower on her way to space from West Texas. Go, baby, go. You can follow along as she speeds up towards space. You see there, the top right corner of your screen. Bottom left corner of the screen is the altimeter. We're just about at max Q, maximum dynamic pressure on the rocket. Max Q confirmed, and she continues to punch her way to space for the 5th time this rocket. A nice clean burn on the BE-3 engine.
All right, and we are back. So that was kind of cool. That was the launch portion. Obviously, it keeps going. But hey, for the sake of time, let's go to the descent, right? So literally 6 minutes later, this thing is coming down. So you can see how, it's going pretty fast. So from about 38 minutes, 22 seconds. To 30 minutes 51 seconds. So you can see that the descent, when you see it, it's split into 2 stages. It's the rocket part, and then there's the capsule part. Okay, so they have separated. All right, so the rocket part comes down first. It's reusable, right? And then then after that, you will see the capsule come down. So we're split into two segments.
Boom, we felt the sonic boom here down in Texas. Look at that beautiful hover.
She sounds like she's just riding it.
Just magic. Look at that.
find it kind of funny.
And touchdown.
Yep.
All right, that was the touchdown, the rocket part, and then of course there's the capsule part, right? The capsule is the one that actually contains the useful payloads, experiments, and whatever else goes inside there, right? So the capsule would have gone really out there, and it's not powered, doesn't have a rocket, so it has to descend by parachute. But it is reusable, so let's see it.
Record for our new Shepard capsule. There go the drogue chutes. And there are the mains. A bit of coning, but that is all right. Reefed and now full inflation of the parachutes. Picture perfect. I can see the capsule from here just off in the distance. Nice and stable descent. Look at that. Look at those big, beautiful windows showing off for you, glistening in the Texas sun. A nice, stable descent. See, it's 16, 15 miles an hour. Last milliseconds, we're going to get the retrothrust system that's going to fire. It's going to kick up the dust, but that's a nice air cushion for the payloads. I see our team has already left our center here. It's going off to recover the capsule, and there it is, touchdown. A beautiful, beautiful launch and landing of the booster and the capsule today. Incredible.
All right, we are back, and wasn't that beautiful? I mean, good job, Blue Origin. Okay, so we got only a few minutes left, so let me let's go back to go talk about astrobiology, or seriously, forget astrobiology stuff. I really just want to talk about aliens, okay? Because what's more interesting? Aliens, no contest. All right, so speaking of aliens, did you guys realize National Aliens Day was on April 26th? Not that, you know, it should be a national holiday, right? Like international holiday, but it's not. Okay, for better or worse. Yes, there is actually a day to celebrate aliens. Gosh, I did not even know that until I looked it up. But I believe this was a nod to the sci-fi film franchise Alien, which premiered in 1979, I think on April 26th. And, you know, it was a pretty cool movie, I guess. I actually don't like it, but I'm sure a lot of people do. I'm sorry. Didn't premiere on April 26th. It's a reference to the moon in the first Alien film, LV-426, where the movie was set, right? Okay. So that aside, UFO statistics, right? So there's as I always say, there is a reporting center for folks who sees things in the sky and don't know where they are. It's the National UFO Reporting Center, and it's been logging UFO sightings across the nation since 1930. That's right, 1930. That's older than NASA, which is pretty crazy. It's been around, 80 years now? More than 80 years, almost 90 years now. Yes, so people have been reporting UFOs for 90 years. At least officially in this country, through the National UFO Reporting Center. All right, so no ties to the U.S. government. category sightings by year and month and date, time, city, state. Okay, so point is, I've read some of those things before, right? And you know, if you have a legit reason, you can post it. Okay, so now it turns out that in different states, I haven't done these statistical analysis myself, but other people with more time on their hands have. And so statistically, depending on which state you are in, you know, you have more or less probability of seeing, you know, UFOs. So for instance, in New York, just give you a few, I'm not going to go through all 50 states. In New York, you have a probability of seeing 1 in 252,400 for a year. Like, okay. There's been, in New York, there's been 7,744 total UFO sightings. Now, the least likely place turns out to be Florida, which is weird because that's where most of the launches take place, right? Maybe aliens don't want to be where human rocket launchers are taking place. I don't know. Those odds are probability is 1 in 341,800. All right. Now, the most likely, this is a good reason to move to South Dakota, which is not known for a place, not known as a place that people like to move to, I don't think. So, but if you go to South Dakota, you have a 1 in 11,200 probability of seeing UFOs. Not bad. So, if you really want to see UFOs, go hang around South Dakota. All right. There's all sorts of objects that have been detected. There were disc-shaped, cigars, orange lights, white and green lights, ones that hover, ones that like go off really fast. All right. There's one case where a UFO was 100 feet off the ground. So, you know, all sorts of crazy cases. I've read some of those to you guys, and for sure you can go through the National UFO Reporting Center website and you'll read a whole bunch of different ones. All right. So this is all cool and all, but, you know, some of you may think, oh my gosh, what is the government doing about it? Is it just, you know, are they still trying to hide things? Well, okay, the government is always trying to hide things to some degree, right? Since there's black ops projects and whatever else. Obviously, everyone knows that. But what about aliens? Well, it turns out that the U.S. Navy is getting a little more transparent, and for good reason, because we don't know what these are, right? So it could be other governments, like, I don't know, Chinese, Russians, who knows? That has some secret stuff, right? Or it could be ETs, and whether do we know they're here for good or for harm? So what they've done, the U.S. Navy has recently decided to implement a policy to allow U.S. military, particularly the Navy and the Air Force, to report these sightings and for investigations to occur. Of course, they also note that this is not going to be open to the public. So, nope, you and I are, unless you're part of the Navy or Air Force, are not going to hear about, you know, oh, UFO sighting by Navy pilot, blah, 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 in blah, blah, blah area. You know, unfortunately, that's not going to happen. But at least, you know, the Department of Defense is openly admitting that that's where they're going to track, okay? Which is kind of cool. Now, they are going to pass along information if it's needed, all right? So, like, for instance, the Defense Department has done this recently in very recent cases before, like 2017, for instance. Remember, there was a funding for a special program called Advanced Aerospace Threat Identification Program, AATIP, which supposedly ended in 2012 but did not. Okay, I don't think it did. So the Defense Department, remember, released 2 declassified videos which showed pilots basically talking about a bizarre, unidentified flying object, bizarre aircraft that appeared to accelerate so quickly, had no measurable means of propulsion, and they were all shocked, right? That was legitimately real. I mean, if you don't believe there's something out there, gosh, what do you think? I mean, they're not, you know, pilots are trained to identify what's going on. They're not like everyday people who mistake a balloon for a UFO, all right? So I'm glad the Navy is doing this. So we shall see what happens, right? And as Seth Shostak, a senior astronomer at the Search for Extraterrestrial Intelligence, SETI Institute in Mountain View, California, says the government is making a smart move. Make everybody happy because it sounds like a move towards transparency, right? So people are less likely to say, oh, the government knows about it and is just hiding everything, because the government's actually investigating it. So we shall see. All right. Well, with that, you should know that you should always be looking up in the sky, right? So this draws to our conclusion of SG2 on Space, episode number 30. Follow us on facebook.com/Facebook.com/TheShen and also need to mention Facebook.com/Action1Media with an ONE this time, Action1 Media, and follow our YouTube channels as well. And never forget, all right, whether or not you choose to listen to the show, whatever you're doing, don't forget to look up, because you never know what you will see.
Peace, brother Atum Ryan. You tuned in to Action One Network.